The National Electrical Code defines portable equipment as equipment that is actually moved or can easily be moved from one place to another according to NEC 400.8. Based on this definition, warming and cooling equipment boxes on wheels would qualify as portable equipment. They are easily moved for cleaning and storage. However, extension cords used to power box fans hung from the ceiling may not qualify as portable equipment. While they can be moved from one location to another, they are not intended to be moved regularly or easily. Temporary wiring is defined by the NEC as wiring installed for a period not to exceed 90 days for the purpose of testing or experimentation as stated in NEC 590.3b. Since the warming and cooling equipment boxes and the box fans will be in place for more than 90 days, they would not be considered temporary wiring. Therefore, extension cords could not be used to power them. GFIs, which are ground fault circuit interrupters, are required by the NEC for all 120-volt, single-phase, 15 and 20 ampere receptacle outlets that are not part of a dedicated circuit serving a single appliance and not located in a dwelling unit as indicated in NEC 210.8b2. Concession stands are not dwelling units, so GFI would be required for any receptacle outlets that are used to power the warming and cooling equipment boxes and box fans. Multiple length GFI protected extension cords are available on the market. These cords can be used to provide GFI protection for equipment that is not plugged into a GFI protected outlet. However, it is important to note that these cords are not a substitute for properly installed GFI outlets. If possible, it is always best to plug equipment into a dedicated GFI protected outlet. The recommended solution for powering the warming and cooling equipment boxes and box fans is to install dedicated GFI protected outlets in the concession stands. This will provide the necessary GFI protection and eliminate the need for extension cords. Therefore, firstly, consider the mobility and intended use of your equipment to determine if it qualifies as portable under the NEC definition. Secondly, remember that temporary wiring, according to the NEC, is limited to installations lasting no more than 90 days, meaning extension cords cannot be a permanent solution. Thirdly, understand that GFI are crucial for safety in non-dwelling locations like concession stands, specifically for 120-volt, single-phase, 15 and 20 ampere receptacles. Fourthly, while GFI protected extension cords offer an extra layer of safety, they should not replace properly installed GFI outlets. Fifthly, prioritize installing dedicated GFI protected outlets to ensure both safety and code compliance for powering your equipment. Now let's delve a bit deeper into each of these aspects. Regarding portable equipment, the key is the ease and regularity of movement. Items designed to be easily relocated, such as those on wheels or those specifically designed for portability, generally fall under this definition. However, equipment that requires significant effort to move or is intended to remain in a single location for extended periods might not qualify. In the case of the box fans, consider whether they are regularly moved for cleaning or maintenance. If they are essentially fixtures, they should be wired as such. Regarding temporary wiring, the 90-day limit is a strict one. This provision is intended for situations where wiring is needed for a short duration, such as during construction or for temporary events. Using extension cords for periods longer than 90 days violates this code and can create a safety hazard. It's important to remember that temporary wiring is not a substitute for permanent wiring. GFI are critical safety devices designed to protect people from electrical shock. They work by monitoring the current flowing in a circuit and quickly interrupting the power if they detect a ground fault, which is a leakage of current to ground. This can happen if someone touches a live wire or if there is a fault in the equipment. The NEC mandates GFI in various locations where the risk of electrical shock is higher, including kitchens, bathrooms, and outdoor areas. The requirement for GFI in concession stands reflects the fact that these areas are often damp and exposed to the elements, increasing the risk of electrical shock. Now let's talk about the specific requirements for GFI protection. The NEC specifies that all 120-volt, single-phase, 15 and 20 ampere receptacle outlets in non-dwelling units, such as concession stands, must be GFI protected if they are not part of a dedicated circuit serving a single appliance. This means that any outlet used to power multiple devices or general-purpose equipment must have GFI protection. There are several ways to provide GFI protection. The most common method is to install GFI receptacles, which are special outlets with built-in GFI protection. These receptacles have a test and reset button and will trip if a ground fault is detected. Another method is to install a GFI circuit breaker in the electrical panel. This type of breaker provides GFI protection for the entire circuit. Finally, as mentioned earlier, GFI protected extension cords are also available. These cords have a GFI module built into the cord and will trip if a ground fault is detected. However, it is important to understand the limitations of GFI protected extension cords. While they can provide an extra layer of safety, they are not a substitute for properly installed GFI outlets. GFI protected extension cords can be easily damaged or misused, and they may not provide the same level of protection as a GFI outlet. Therefore, the best practice is to always plug equipment into a dedicated GFI protected outlet whenever possible. In the case of the warming and cooling equipment boxes and the box fans, the recommended solution is to install dedicated GFI protected outlets in the concession stands. This will ensure that all equipment is properly protected and that the installation complies with the NEC. The installation of dedicated GFI protected outlets may require the services of a qualified electrician. The electrician will be able to assess the electrical system in the concession stands and determine the best way to install the outlets. The electrician will also ensure that the installation complies with all applicable codes and regulations. In addition to installing dedicated GFI protected outlets, it is also important to regularly inspect the electrical equipment and wiring in the concession stands. Look for any signs of damage, such as frayed cords, cracked outlets, or loose connections. If you find any damage, have it repaired immediately by a qualified electrician. It is also important to ensure that all equipment is properly grounded. Grounding provides a path for fault current to flow back to the electrical panel, which helps to prevent electrical shock. The grounding system should be inspected regularly to ensure that it is in good condition. Finally, it is important to educate employees about electrical safety. Make sure that they understand the hazards of electricity and how to avoid them. Teach them how to properly use electrical equipment and how to recognize and report electrical hazards. By following these recommendations, you can create a safe electrical environment in the concession stands and protect employees and customers from electrical shock. Now let's explore some common misconceptions about GFI. One common misconception is that GFI prevent all electrical shocks. While GFI provide excellent protection against ground faults, they do not protect against all types of electrical shock. For example, a GFI will not protect you if you touch two live wires at the same time. Another misconception is that GFI are only needed in wet locations. While GFI are particularly important in wet locations, they are also required in other areas where there is a risk of electrical shock, such as kitchens and garages. It is also important to understand the difference between a GFI and a circuit breaker. A circuit breaker is designed to protect against overloads and short circuits. It will trip if the current in a circuit exceeds the breaker's rating. A GFI, on the other hand, is designed to protect against ground faults. It will trip if it detects a leakage of current to ground. While both GFI and circuit breakers are important safety devices, they protect against different types of electrical hazards. Let's move on to some practical considerations for installing GFI outlets. When installing GFI outlets, it is important to choose the right type of outlet for the application. There are several different types of GFI outlets available, including standard GFI receptacles, decorative GFI receptacles, and weather-resistant GFI receptacles. Standard GFI receptacles are the most common type and are suitable for most indoor applications. Decorative GFI receptacles have a more stylish appearance and are often used in kitchens and bathrooms. Weather-resistant GFI receptacles are designed for outdoor use and are protected against moisture and corrosion. It is also important to install GFI outlets correctly. The outlet should be installed according to the manufacturer's instructions and should be properly grounded. The wiring should be tight and secure, and the outlet should be properly secured to the wall. If you are not comfortable installing GFI outlets yourself, it is best to hire a qualified electrician. The electrician will be able to install the outlets correctly and ensure that they are properly grounded. Now, let's consider the implications of using extension cords with GFI protection. While GFI protected extension cords can provide an extra layer of safety, they should be used with caution. Extension cords should never be used as a permanent wiring solution. They should only be used for temporary applications, such as powering equipment during cleaning or maintenance. When using extension cords, it is important to choose the right type of cord for the application. The cord should be rated for the amperage of the equipment that it will be powering, and it should be long enough to reach the outlet without being stretched or tangled. It is also important to inspect the extension cord before each use. Look for any signs of damage, such as frayed cords, cracked insulation, or loose connections. If you find any damage, do not use the cord. Finally, it is important to avoid overloading extension cords. Overloading an extension cord can cause it to overheat and potentially start a fire. To avoid overloading an extension cord, do not plug too many devices into it and do not use it to power high amperage equipment such as refrigerators or air conditioners. In summary, to ensure the safety of your minor league baseball stadium concession stands, prioritize the installation of dedicated GFI protected outlets for all 120-volt single-phase 15 and 20 ampere receptacles. This solution complies with the NEC guidelines, eliminates the risks associated with extension cords used as permanent wiring, and provides superior protection against electrical shock. Remember, GFI are not a substitute for proper wiring and grounding, but an essential component of a comprehensive electrical safety strategy. By understanding the NEC requirements, common misconceptions, and practical considerations, you can create a safe electrical environment for your employees and customers.